Advanced scripting, advanced error handling. This is the advanced of the advanced. A lot of what we talked about in the previous nugget is a good set of basics to start with, but then we start to fall into kind of the caveats and the edge situations and some weird little under the hood differences that I want to make sure you know about. We're going to focus on some of the nitty gritty details and differences, things that don't always pop up in PowerShell's documentation. We're going to incorporate some quick reviews of some basic concepts, but I'm largely going to be referring you to the previous nugget where we got those out of the way. And we'll definitely be playing into how error actions affect what we're doing, but we're primarily going to be talking about different ways of capturing the error. In other words, not so much figuring out if an error happened, although that's going to be part of the discussion too, but also the different ways of figuring out what the error was and how these things are all exactly not quite the same, how they're very, very close to being the same, but often confusingly different. So hopefully this will clear all that up. One of the first things you'll have to understand is that PowerShell is built on top of the .NET framework. And the .NET framework, everything in it, when it runs into an error condition, knows how to produce exceptions. Now, an exception is actually a very specific type of object. In fact, it has a base of system.exception, and all these different types of exceptions inherit from there. And those exceptions are designed to provide a good amount of information about what happened and so forth. But PowerShell has other things going on. PowerShell, from PowerShell's perspective, that exception happened maybe inside of a script. So there's the name of the script, the line number it occurred on. There's this other contextual information that kind of goes along with the exception. So PowerShell combines all that information together for us in something called an error record. Now that error record provides access to the underlying .NET exception as well as all of the contextual information from PowerShell itself. So let's take a look at a quick example. Get content does not exist.txt. Okay, that caused an exception, but it also created an error record. And by default, PowerShell wants to pop those into this error collection. Now, $error will contain all of the error records that have happened up to a maximum. And I'll show you how to set that maximum in a second. Once it hits that maximum, the oldest error record will come out to make room for the new one. And the latest one is always here at index 0. So that tells me what we found. We can look at some of the properties of that. We can see the target object. So what I was trying to get to, in other words, what the command was trying to operate against was does not exist.txt. We can look at things like the category info. Well, this was an object not found category. The activity we were trying to run was get content. We got an item not found exception from the .NET framework, and that's why we created the error record, and there's the target name, and the type of that is a string. So if you were trying to operate against an Active Directory user, the target type might be an Active Directory user instead, so that what we're operating against can be things of a different type. I can also look at its invocation info. And this tells me what was happening. Well, the command that was happening was get content. We didn't have any bound or unbound parameters. It was line 1 of the script because in PowerShell's head, everything kind of is a batch. And so because I was running this interactively, anytime you do that, it's always going to be line 1. This command is number 6 in PowerShell's history, so I could go find the command there. And there's a little position message that it's trying to tell me with these squiggly underlines, if you pretend these are like red squigglies, like in Word, it's telling you what it had a problem with. So if I had a big multi-part command line, this helps draw my attention to where the problem was. It'll give me the root of the script, the command path, the length of the pipeline, everything. So there's a lot of additional PowerShell flavored info that lives there. Now your scripts, as they intercept errors, can use that information. So we've already talked in the previous nugget a little bit about terminating and non-terminating errors. And it's important to understand that if you plan to intercept an error, you do need to know the difference. As a general rule, most errors produced by most commandlets are non-terminating unless you make them terminating by using error action stop, which I showed you how to do in the previous nugget. So we've looked at this error variable a little bit. The latest is always in 0. If you're in a script, and you want to get a little bit more control over that, you can do something like error.clear. That will wipe out what's in error so that only, only your latest error will wind up being in there. So it's kind of a way to just, I guess, get a little more control over that situation so that you kind of have a better grasp of what's in there and what's happening to it. So in this example, now error contains just that one thing. There is a variable that lets us control how many it will store, and this is stored in the variable drive. So maximum error count right there, you can change maximum error count. You can see it's going to keep a rotating 256 errors. If you change that, it's not a permanent change. It only affects this PowerShell window, and any new PowerShell windows you open will always have a maximum error count of 256. Now, if for some reason you need to change that at the top of a script, it's very easy. Just maximum error count equals whatever. Make it smaller maybe. It's not a valid value. I think we have to make it at least 256. That's 512 is fine. I think it doesn't want to go below 256. So we can use that. We can use that in our scripts. Keep in mind that a lot of people in a script do consider it a bad practice to clear that variable because it's a global variable, meaning you're wiping out other variables that may have occurred elsewhere in the scope. So you don't necessarily want to wipe it out unless you know for a fact you're not wiping out information that somebody else might have needed to use. Now, one thing I did in the previous nugget is I showed you the error variable parameter. And it's a common parameter, so all PowerShell commands and functions and scripts all have that parameter, and it lets you specify a variable other than the built-in $error collection for an error to go into. Let's take a look at that real quick. Just to make our comparison easy, I'm going to start by clearing error. And I'm going to say get content, not exists.txt, error variable x. Now again, when you specify this, variable names do not include the $sign. If I did $x, it would try to put the error variable in a variable named whatever was in $x. Now I don't think I've defined $x, so that would be a problem. If I do it this way, then x will be my error variable. So there we go. Let's take a look at the error 0. Right, that's what we expect. Let's pipe it to get member, shows that it is of the type error record. Now let's look at x. Now let's pipe x to get member, showing that it is also the same error record. So whatever would have gone into $error is the same thing that we're picking up using that error variable. I like to use error variable rather than $error 0 because it's a little bit more deterministic. It lets me give it a nice variable name. It also means that I've captured that command's error into my own variable. One problem you can run into programmatically with using $error 0 is if you commit another error while you're dealing with the first one, the error you're dealing with will now be in $error 1, and the most recent error will be in $error 0. So by having it in my own variable x, that's never going to get overwritten by anything else, and I get to keep it and use it for however long I want to. We've talked about error action and the $error action preference. We did that in the previous nugget. And I talked about how those allow you to take a command's normal non-terminating errors and turn them into terminating exceptions, things that we can actually trap. And I also talked to you in the previous nugget about the try, catch, finally construct, which is kind of the perfect ideal way to try and catch exceptions. The trick being that once you're in a try block, and let's let me open up my ISE here just so I can quickly refresh you on this. And we'll open my example module because this is where I actually showed you this in the previous nugget. Once you're in the try block, so long as you are producing a terminating exception, which typically most commands are going to require you to do -error action stop, then that will cause the catch block to execute. I also mentioned that we're talking about a perfect world here. There are commandlets who, because of the way they are written, even if you specify -EA stop, won't generate a terminating exception, which means they can't trigger a catch block. Those are badly written commands from my perspective, but they certainly happen. They're out there. You may run into them. What might you do in that case? Well, there's a couple of different things folks will do. Let's say I did my command, do something. I gave it error action stop, and I put it in a try block. Oh, darn it. I put it in a try block, and at the end of the try block, I put a catch block, and I did something in here to deal with the error. And in testing, I realized that even with minus error action stop, when do something runs into an error, this was never executing, meaning this isn't doing any kind of terminating exception. Well, another approach then might be to chuck on error variable, capture that, and then see what's there. So let's look at that real quick. Let's see what happens when an error occurs versus an error not occurring. Pretty sure I have, let's see, get content, computers.txt. Yes, excellent. Error variable x. Okay, no error occurred, so what is in x? Nothing. $x count. 0. That's important. X equals null. Can't really do that comparison. What you do is you want to check the count property of x, because even if no error occurred, that variable will be an array. It will just be an array of 0 elements. Let's do exactly the same command again, but this time give it a file that isn't there. X.count is now 1. So that might be one way to do this. Instead of using a try-catch block, since we've kind of determined it isn't going to work, then I might say if x.count is greater than 0, then do something else to deal with the error. So that can be another way of determining if an error happened in cases where the standard try-catch looking for a terminating exception isn't working. Now, sometimes you might actually want to catch a non-terminating error. You can't use a try-catch block for that. Keep in mind that the catch block will only be triggered by a terminating error, which means the command was told to stop processing. For example, get content can actually accept multiple things in its path. So let's do computers.txt and not exists.txt and comps.csv. Let's just have it read all of those. I'm not going to give it an error action of stop. Oh, heck, you know what I do want to do, though, before I do this? Let's put this on the clipboard so I don't have to type it again. $error clear. All right, now let's paste that back in. I'm not going to tell it error action stop, meaning I'm going to give it an error variable of x, meaning this should work. This won't work, but I'm not wanting the command to stop. I want the command to continue so that it processes the third file. I want to see what happens to the error in this situation. I want to give it a fourth file too that also doesn't exist. Okay, so first one worked, second one didn't, third one worked, last one didn't. Let's look at what's in error. What's in error, not here, and then not exists. So you'll notice this was the first error it ran into, and this was the last error it ran into. Because the error collection puts the last error first, that's what we have. The most recent error here, and then this one got bumped down to second place. If we look at x, it's in the opposite direction. So when you specify minus error variable, PowerShell actually stacks the errors, if there are multiples, in order. So the first one is first, x0, and the second one is second. So that's really the big difference in non-terminating errors. You can't use a catch block. So if you wanted to execute a command like the one I just did, this one, and you wanted to see if there were errors, you could check x.count. Yep, there were 2 errors, so I'm going to have to deal with them. And you could do that in an if construct, just like I did here. And then you could get to the actual errors using these indexes. You could even go through them. For example, for each e in x, let's just do x invocation info. Actually, it would be e. Sorry about that. So in my little thing there, once I said, yeah, I've got more than 0 errors, now I can enumerate them and deal with them one at a time if you want to, because this X is just a collection or an array of error records. So if you're dealing with non-terminating errors, that's the big difference you'll have to be aware of. So let's talk about dealing with terminating exceptions. Let's do a little bit less undoing than that. All right, here we go. Here in the catch block, let's talk about what happens here. Let's assume I put an error variable on this command. Call it error variable X. So what do I have in the catch block? Well, first of all, $_ will contain the current error record object for the terminating error that occurred. Assuming this command properly produces a terminating error when I tell it error action stop, then this will contain the error record. So will that, and so will that. So those, well, actually let's get back to X because there's some weird stuff there. Those two should always be equal. So error 0 should always contain the error object for the terminating error. $_ will do the same thing. It is important if you plan to use the error from either of those that you copy it out, right? You either do this or you do this, because there are other things that can go on in the catch block which will make error 0 be something else other than what this command produced, and $_ can similarly get hijacked in certain situations. So if you want to use those, it's important to do so. So now let's talk about what's in $X. It can vary. If this was an advanced function that threw a terminating error as opposed to like a commandlet, then $X will contain 2 identical error record objects for that terminating error. And in older versions of PowerShell, like version 2, those error records will be followed by 2 identical objects of the type runtime exception, and that contains an error record property which gets you back to the error record objects that are already in $X. So if this do something was an advanced function, meaning a script that someone called, then $X is going to contain a bunch of wacky stuff. You're going to have to make sure you look at it as you're developing, test it so that you know what to expect and you know which one to work with. Now, on the other hand, if do something was a commandlet and it threw a terminating error, then $X will contain a single record, but it will not be an error record object. Instead, it's going to be called something that's a commandlet invocation exception. Now, that will contain an error record property, which means you could do this. X.errorRecord, if do something was a commandlet, would be equivalent to whatever would normally be in $_. Yes? So that property gets you the error record object that you would have expected to be in there normally. If this was an advanced function and you made it throw a terminating exception by using error action stop, then $X will contain an action preference stop exception. Then it will contain 2 identical error record objects. The action preference stop exception also will have an error record property that lets you get to it. So we've got a couple of different situations here. I'm going to summarize them. Actually, I'm going to start summarizing them for you. So here's what you need to do. First of all, do you want to just learn one thing instead of 20 things? Because if you want to learn one thing, just grab that and copy it off to something else. However, right, that's what you're going to do. You're going to actually grab advanced function, terminating exception. It'll contain 2. Nope, you just want this. Okay, I'm going to stop typing now. We're going to go back to the GUI. That's what you want. Commandlet through terminating exception. In this case, you are not going to get anything. You're going to get an X0 dot error record, and that will get you the error record you're after. advanced function through non-terminating, but you used EA stop. Again, that's what you're going to use. So in this case, this first one up here, we're assuming that we ran this without error action stop, and internally the advanced function tossed a terminating exception. On this last section, the difference here is we used EA stop, error action stop. The advanced function threw a non-terminating, but this made it terminating, triggered the catch block, and you're going to want to use $x index 0 dot error record. Right? Simple enough. And then the last situation is a commandlet through a non-terminating, but you used EA stop to make it terminating. Now in this case, error variable will have a single object of the type action preference stop exception again, and it will have the error record that you're after. So x0 dot error record. Or in any of these, grab that or grab that. So you can decide what you want to do. The difference with these four is that nothing is going to hijack that x and take it away from you because you did it up here with the minus error variable. The difference with these is that they can be hijacked. So you may want to just pull them out. One of these is always going to get you the error record that you're after. So as I said, if you only want to learn one thing and keep one thing in your head and not have to go figure out what the situation is, those should always work for you. If you're going to use error variable and thereby having a deterministic variable that can't be taken away from you and hijacked like these two guys can, then you're going to have to know what the situation is so that you can know how to get to the error record that was produced. Now, in terms of figuring out if an error happened, right? So we've talked about two different things really. How to figure out if an error happened, and that's what the catch block can help you do because it only executes if a terminating error happened. We also talked about the trick of checking x.count to determine if an error happened because it'll be 0 if none did. There's another technique you can use to figure out if an error happened. Let's start with get content with a file that does exist and look at $question mark. It's true, meaning the command completed successfully. Do the same thing with a bad file name. $question mark is false. So that's a quick and dirty way of determining if a command completed successfully. However, it kind of depends on the individual command reporting that. Some commands will not correctly report that. They'll report true, I completed successfully, even though in your mind you might not think about it as success. So, for example, it's experimentation. You've got to figure out what the command is going to do before you rely on it. Ping localhost. Okay, 1, 2, 3, 4. $question mark, true. Okay, ping not here. We're doing the name lookup part right now. It's trying to turn that into an IP address, and this is not going to happen. Nope. Nope, couldn't find the host. $question mark, false. So in this case, the ping command, when it failed to look up the name and turn it into an IP address, set its return code to not successful, and PowerShell was able to interpret that into $question mark being false. What about ping 10.5.5.5? Now this is not a legal IP address on my network, so I'm expecting, yeah, and there we go. We got a reply, destination net unreachable. That's from my router. Request timed out. I have to work on my router. $question mark says true because the command completed successfully. Ping ran without error. Ping was able to get the IP address because I gave it one. It sent out packets. It did get a reply back, and so it set its result to true. So all I'm saying here with $question mark is you need to experiment with it in a variety of situations and make sure that you and the command agree on a definition of successful or not. Now that's especially important when working with external commands because they're not going to return an error record. I can't run ping with minus error variable. Ping isn't a PowerShell command. It's an external application. It's ping.exe. So there is no error variable. So determining what went wrong can sometimes be more difficult. I might have to capture its output and parse it with a regular expression or something. $? Can sometimes tell you if it completed successfully, but you might not agree on its definition of success. So just make sure you're aware of that, you're aware of its existence, and you know that you've really got to test all the different possible cases before you rely on it. So I know that's a lot to cover, but I think it's important that you know about all of those differences. So we did a quick little review of the basics, the stuff that we covered in the previous nugget. Talked to you about the different error actions, and we spent a lot of time on these guys, how to actually capture the error. Now there's a lot of different things that you can do in Windows PowerShell in terms of errors. Things that don't throw terminating exceptions. You can't rely on error action stop. You might have to put a logical construct and check to see if this contains anything after you clear it out, or run an error variable and check to see if that contains anything before you clear it out. But the idea is now you know that these things are not all exactly the same, and you should know for any given situation you find yourself in the right way to figure out what an error was, as well as whether or not an error happened. I hope this has been informative for you, and I'd like to thank you for viewing.